Okay, so problem 7.22. Prove that the logarithm of x divided by x is smaller than 1 over e for all x greater than 0, and that x are different than e, right? So if x is equal to e, as you can see, this is going to be 1 divided by e, so it's the same, right? So let's see, so we can try to see that the function f, just like the previous example, right? The logarithm of x divided by x is in, so this is smaller than 1 over a, right? That has a maximum at 1 over a, right? Maybe it's increasing before and decreasing afterwards. Let's compute the derivative, right? So the derivative is going to be, well, x squared in the numerator, in the denominator, sorry, here, and you have x times 1 over x, 1, and then we have minus, and then the logarithm of x, right? Now this thing, the derivative is 0 only when logarithm of x is equals 1, which is that x equals e, right? So f prime at e is a 0, right? Now the denominator is x squared, so it's always positive. The logarithm of x is smaller than e whenever x is smaller than, smaller than 1 whenever x is smaller than e, right? So if x is smaller than e, f prime is positive. And if x is greater than e, f prime is negative. So that means that the function increases and then decreases, and there reaches a maximum at e, right? So this is f at e, right? And f at e, we know it's 1 over e, right? F at e is 1 divided by e, right? So if x is different than e, the function is going to be smaller than 1 over e. Okay, so we have proven the first part. Now, this inequality is the same as proving that e to the x is greater than x to the e, right? So logarithm of x smaller than 1 over e is the same, is equivalent to this. Okay, so let me see how we can get that. So we have, let's see, the logarithm, let's see how to express this. We have the logarithm of x, and we can, this is smaller than x divided by e, right? And so if we take, let's see, right, sorry, the logarithm, how to say, x is greater than e times the logarithm of x, right? That's it. If you see here, right? So we're taking x here and then e here, and then this is the same as saying that x is greater than the logarithm of x to the e. Now if we take exponentials in both sides, e to the x is greater than x to the e, right? And that comes from the fact that the exponential is an injective function, so if this is greater than this, then taking the exponential is going to be greater, right? And that's the end of the problem.